Humanity has always looked at the night sky with a strange mixture of fear and hope. Long before rockets, before telescopes, before science had names for the stars, humans believed the heavens were alive, watching, judging, waiting. And then, in the late 20th century, for the very first time in our history, we did something no civilization had ever done before. We built a machine, aimed it at the darkness, and told it to keep going, forever. That machine was Voyager. Voyager was never meant to become a legend. When NASA launched Voyager 1 and Voyager 2 in 1977, they were simply ambitious planetary probes, designed to take advantage of a rare planetary alignment that occurs once every 176 years. The mission plan was bold but limited. Visit Jupiter, Saturn, and, if luck allowed, Uranus and Neptune. No one seriously talked about interstellar space. No one imagined that these spacecraft would still be alive nearly half a century later, silently drifting far beyond the sun's influence, carrying with them the story of Earth itself. As Voyager accelerated away from home, it passed familiar planets one by one, each flyby revealing worlds more violent and alien than anyone had expected. Jupiter's raging storms, Saturn's razor-thin rings, Uranus spinning on its side like a cosmic accident, Neptune's supersonic winds, each encounter reshaped planetary science forever. But after the last images were sent home, something remarkable happened. Voyager did not stop. There was no finish line, no destination, only direction. Beyond the outer planets lies a region so distant and faint that even sunlight becomes weak and fragile. Here begins the heliosphere, the vast bubble created by the solar wind, expanding outward as the sun pushes against interstellar space. For decades, Voyager traveled toward this invisible boundary, carrying instruments that could feel changes humans could never sense. Slowly, subtly, the pressure changed. Cosmic rays intensified, the sun's influence weakened, and then, in 2012, Voyager 1 did something historic. It crossed the heliopause. Humanity had officially entered interstellar space. But the most haunting question was never when Voyager would leave the solar system. The real question was always this: where is Voyager headed now? Voyager does not travel toward a planet, a star, or even a specific destination. It moves along a cosmic trajectory shaped by gravity, momentum, and time itself. Voyager 1 is heading toward the constellation Ophiuchus, while Voyager 2 drifts in a different direction entirely, toward Sagittarius. But these constellations are illusions, flat patterns painted on the sky by distance and perspective. The stars within them are light years apart, moving independently through the galaxy like ships in a vast ocean. If Voyager were to encounter another star system, and statistically, that possibility exists, it would take tens of thousands of years. In about 40,000 years, Voyager 1 will pass within roughly 1.6 light-years of a star called Gliese 445. By then, Earth may not exist as we know it. Human languages may be unrecognizable. Civilizations may rise, collapse, or vanish entirely. Voyager will continue, indifferent to all of it. And yet, Voyager is not empty. Attached to its side is one of the most emotional objects humanity has ever created, the Golden Record. A gold-plated copper disc containing sounds, images, music, and greetings from Earth. It holds the laughter of children, the cry of a newborn, the sound of waves breaking on a shore. It carries Bach, Beethoven, Chuck Berry. It speaks in dozens of human languages, saying a simple thing: this is who we were. This is where we came from. The Golden Record was never meant to be practical. The chances of it ever being found are astronomically small. But that was never the point. It was an act of defiance against cosmic silence. A message thrown into the dark, not because we expected an answer, but because staying silent felt worse. Today, Voyager's power is fading. One by one, its instruments are being turned off to conserve energy. Sometime in the 2030s, Voyager will fall completely silent. No more data, no more whispers from the edge of existence. Just a small, human-made object drifting endlessly through the galaxy, long after its creators are gone. Voyager does not know it represents us. It does not know it is the farthest object humanity has ever built. But in a strange way, Voyager is our future and our past combined, a reminder that no matter how small we are, we still dare to reach beyond the sun and ask the universe a question. And that question echoes still. Because if we can send a message into interstellar space, what if something else has already done the same? If Voyager represents humanity's first whisper into the cosmic ocean, then 3I Atlas feels like something answering back, quietly, mysteriously, and without explanation. It did not announce its arrival. It did not ask permission. It simply appeared, moving against expectations, carrying with it questions that modern science is still struggling to fully understand. For centuries, humans believed the solar system was a closed neighborhood, a familiar cosmic home defined by predictable orbits and known rules. Then interstellar objects shattered that illusion forever. The story of 3I Atlas begins not with speculation, but with routine observation. Atlas, the asteroid terrestrial impact last alert system, is a network of telescopes designed to scan the sky for threats to Earth. Night after night, it watches silently, capturing faint streaks of light that most humans will never see. Among millions of ordinary detections, one object stood out. Its speed was wrong, its trajectory was wrong, and most importantly, its origin was wrong. Unlike asteroids or comets born within our solar system, 3I Atlas was not gravitationally bound to the Sun. Its path was hyperbolic, meaning it was passing through, not orbiting, not returning, not staying. This single mathematical detail changed everything. Because hyperbolic trajectories do not belong to local objects. They belong to travelers. To understand why this matters, we need to understand how violently rare such visitors are. For billions of years, our solar system existed in relative isolation. Rocks and ice formed around the Sun, shaped by its gravity, trapped in predictable loops. Interstellar space, by contrast, is vast beyond imagination. The distance between stars is so enormous that even objects moving at tens of kilometers per second can wander for millions of years without encountering anything at all. For something to reach us from another star system requires extraordinary circumstances. And yet, 3I Atlas did. Scientists quickly realized that this was not the first such visitor. In 2017, Oumuamua shocked the world as the first confirmed interstellar object ever detected. Then came 2I Orso, clearly a comet from another star. Now 3I Atlas entered the conversation, each visitor stranger than the last, each raising deeper questions. Were these objects rare, or had they always been there, unnoticed, slipping through our system like ghosts while humanity lacked the eyes to see them? As astronomers studied 3I Atlas more closely, its behavior refused to settle neatly into existing categories. Its brightness fluctuated in unusual ways. Its speed suggested it had been traveling through interstellar space for an unimaginably long time. Some models suggested it may be older than our solar system itself, a relic from another stellar nursery, formed around a star that may no longer even exist. Think about that for a moment. Before Earth formed, before the Sun ignited, before the planets had names, this object may already have been drifting between stars. The implications are staggering. If 3I Atlas truly originated elsewhere, then it carries within it chemical fingerprints from a completely different planetary system. Different pressures, different temperatures, different histories. Studying such an object is like holding a fossil from another universe, not because it comes from another universe, but because it comes from another story of star formation, one that unfolded far away and long ago. Naturally, speculation followed. Whenever science encounters something unfamiliar, imagination rushes in to fill the gaps. Could 3I Atlas be artificial? Could it be debris from a destroyed world? A fragment ejected during planetary chaos? Scientists are careful here, and for good reason. Extraordinary claims require extraordinary evidence. No direct proof suggests that 3I Atlas is anything other than natural. But the mere fact that such questions are being asked tells us something important. Humanity is no longer confined to studying its own backyard. We are now detecting objects that were never meant to be found. The journey of 3I Atlas likely began in violence. Young star systems are chaotic places. Massive planets migrate. Gravitational encounters sling objects outward at incredible speeds. Entire worlds can be destabilized. A close encounter with a giant planet could have been enough to eject 3I Atlas from its home system, sending it on a lonely voyage through interstellar darkness. No light, no warmth, just cold, endless motion. For millions, perhaps billions, of years, it traveled alone. And then, By pure cosmic coincidence, it passed near our sun. Unlike Voyager, which was built with intention, 3i Atlas has no message attached. No record of sounds or greetings. But in its silence, it speaks volumes. It tells us that planetary systems are not sealed. That matter travels between stars. That the galaxy is not static, but alive with motion, exchange, and collision. The boundary between here and out there is thinner than we once believed. There is also something deeply humbling about the timing. Humanity has existed for only a fraction of Earth's history. Our technological civilization spans mere centuries. And yet, in this tiny window, we are alive at the exact moment when our instruments are finally sensitive enough to detect interstellar wanderers. If Atlas had existed 100 years earlier, 3i Atlas would have passed unnoticed. If it arrives 100 years later, future observers may view it with tools far beyond our own. We are catching the universe mid-sentence. As 3i Atlas continues on its path, it will not stay. Like Oumuamua and Borisov before it, it will leave our solar system forever, carrying with it no memory of us. It will not slow down. It will not turn back. One day, it will cross the heliopause just as Voyager did, except in reverse, re-entering interstellar space, becoming once again a nameless traveler among the stars. And here is the unsettling symmetry. Voyager is leaving the solar system, carrying a message outward. 3i Atlas entered the solar system, carrying a mystery inward. One is deliberate, the other is accidental. Together, they mark a turning point in human awareness. For the first time in history, we are not just sending objects into interstellar space, we are recognizing those that come from it. The galaxy is no longer an abstract backdrop. It is a place of exchange, of visitors, of encounters separated by unimaginable distances and timescales. So where did 3i Atlas come from? The honest answer is this: we may never know its exact birthplace. The galaxy has been turning for billions of years. Stars drift, clusters dissolve, the trail has been erased by time. But perhaps that uncertainty is the most important lesson of all, because it reminds us that the universe is far larger, older, and more dynamic than our need for tidy answers. Voyager carries our story outward, hoping someone, somewhere, might listen. 3i Atlas arrived uninvited, reminding us that we are not alone in motion. And between these two journeys, one leaving, one arriving, humanity stands at the edge of a new era, no longer just observers of the cosmos, but participants in a vast, ongoing exchange across the stars.